Welcome to our notes. This is the CLO for this lesson. It says students will be able to create, in writing, equivalent expressions using backwards order of operations and exponents and the following language: if-then statements, operation, order of operations, isolate, eliminate, inverse, and identity. In your own words, go ahead and tell me what you think we're going to learn in this lesson. So I'm going to start with the vocabulary words in our notes. So the word operation is just a big word for math. So things we can do in math, some normal operations, things we can do is we can add, we can subtract, we can multiply and divide. So those are some major operations. You've also learned another one recently called an exponent. And so yes, exponent. You've also learned about the square root, but I'll show you in a minute that square roots are just exponents. In math, whenever we do math, there is something known as the order of the operations. So order of operations tells you the order that you must perform math in. Which one is the strongest? You do that one first. Then the next strongest, you do that next. And you follow the order of operations, and those are the rules that you have to follow, and you always have to do math in the order of operations. And we will talk about those. However, our goal of these notes is to solve for x. And in order to solve for x, you always do backwards order of operations. So when we do backwards order of operations, what ends up happening is that our goal to solve for x, another word for solve is to get it alone. So our goal is to get x all alone. And a big word for get it all alone is isolate. So isolate means to get alone. And then in order to get that variable alone, we have to eliminate all the things around it. So eliminate means to cancel out or get rid of. So we're going to eliminate things that are around x and make them go away so that we can isolate x to get it alone. So I told you in order to eliminate things, we're going to use backwards order of operations. However, the fancy name to eliminate something is to use the inverse. So the inverse of an operation is what you have to do to that operation to make it eliminate. Another way to think about it is what undoes something. So you already know a bunch of operation inverses. For example, let's say I take some number like 5 and I add 2. Well, now I'm at 7. Let's say I want to undo the fact that I added 2 and I want to go back to 5. How do I undo adding 2? By subtracting 2. And then I'd go back to 5. In the same way, if I subtract 2, I'm at 3. In order to go back to 5, I have to add 2. Because adding and subtracting are inverses. The next one is that multiplying. And what? What undoes multiplying? Dividing. Multiplying and dividing are inverses. They'll undo each other. These two you should have known from your first year of math. The new one that we're going to work with is exponents. So what undoes an exponent? So basically, the one you want to focus on today is that x squared. What undoes x squared? What do you think? What's your guess? The square roots. So the square root of something and x squared undo each other. They are inverses. I'm just going to show you that real fast. I'm going to pick an x to be 7. Well, 7 times 7 is 49. Well, if I want the answer to go back to 7, to undo it, if I were to take the square root of 49, the answer ends up being 7. So it does the whole thing where it undoes it. It goes back. Same thing if I reversed that. If I have the square root of some number, like the square root of 25, square root of 25 is 5. But then if I were to go and square 5, it would go back to being 25 because 5 times 5 is 25. So square root and squareds undo each other. So I'm not going to spend time in this video proving why this is true. It kind of takes a long time to prove it. So I have a different video in the skill building section all about inverses. And I'm also posting it in this video, but it's an optional video. You don't have to watch it. But if you want to understand why adding and subtracting are inverses or multiplying and dividing are inverses, you can go watch that video. So to show what I mean, we're going to do some examples of this. So whenever I solve for x, in order to cancel or eliminate a term, I have to do its inverse. So here's how it works. You always want to draw a line at your equal sign because it acts like a wall and it separates your two things in half. Then our goal is to solve for x, which means isolate for x, which means get x all alone at the end. So right now there's a minus 5. The inverse of subtracting is adding, and adding 5 undoes the fact that we subtracted 5. But I always have to keep my equations balanced. So if I add 5 to the left half, I also have to add 5 to my right half. So then when I do the math, this x, nothing happened to it, nothing's beneath it, so it comes down. Minus 5 plus 5, they were inverses, so they eliminate, they cancel. And there's 0, but I don't ever have to write plus 0. There's no point of writing that. It's just nothing. So then the equal sign's still here, and then 12 plus 5 is 17. So the answer for this one is x is 17. If I were to do it with adding, this is x plus 4. To undo adding, we subtract. We have to do it to both sides. The x comes down. The plus 4 minus 4 cancels. Negative 10 minus 4 is negative 14. So that was adding and subtracting. If I do it for multiplying and dividing, remember 3x means 3 times x. So to undo timesing by x, the inverse is division. So I'm going to divide both sides by 3. 3 divided by 3 cancels and becomes just 1x, but I don't have to write the 1. Negative 12 divided by positive 3 is negative 4. So in this case, x would equal negative 4. If any of these are confusing you, like the arithmetic, like why the answers are the answers, go watch warm-up videos on either adding and subtracting or multiplying and dividing if this is the part that confuses you. So when you have a fraction, remember fractions mean times by the top, divide by the bottom. So I'm going to start with the fact that it's dividing by 7. So to undo dividing by 7, I have to multiply this side by 7, and I have to multiply this side by 7. So multiplying and dividing are inverses, so these two cancel. So I still have the negative 4 and the x. And then on the right, 8 times 7 is 56. Finally, negative 4 times x, or multiplied to x. To undo that, I have to divide it away. Because negative 4 divided by negative 4 cancels and becomes 1x equals 56 divided by negative 4 is negative 14. So that was a multiplying and dividing one mixed. This one's just the square root. Remember, the inverse of the square root squared. So I'm going to put this side in a parenthesis and square it. And put this side in a parenthesis and square it. So this square root and squared cancel, so I'm just left with x equals, and then 5 squared, 5 times 5 is 25. And then finally, if I started with an x squared, to undo that, I could either do parentheses 1/2, but remember that's the same thing as square root. So I can square root both sides. Square root and squared canceled, so I'm just left with x equals the square root of 9. If you put it into a calculator, you'd get 3 because 3 times 3 is 9. But remember, it's always positive 3 and negative 3. Because when you take square roots, you want both the positive and negative answer. So that's how all the inverses work. Whenever you have to solve for x, you're always going to do backwards order of operations when there's a lot more than this, because each one of these were only like one step. This one was 2 steps because I had a multiply and a divide. But usually it's only, all of these were only one step. However, when there's a ton of steps, you have to use backwards order of operations. So let's talk about the order of operations. If you learn PEMDAS, I have a skill building video that's about PEMDAS and why sometimes it can cause an issue versus GEMS, which usually causes a lot less issues. So I'm going to teach using GEMS. So the order of operations using GEMS is G is for grouping. So anything that groups things together. Some things that group things together are parentheses, but then so do fractions, so do roots. E then is for exponents. M is for multiply / divide. Because remember, multiplying and dividing are the same thing. Dividing is just multiplying by a fraction. So it's not that one's stronger than the other one. It's just whatever one comes first when you read it left to right, because you always read from left to right. So then the S is for subtracting / add, because again, all subtracting is adding a negative number. So secretly adding and subtracting are the same thing. So they're of equal strength. So again, it's whichever comes first when you read it from left to right. This is the strongest one. You always do grouping first, then the exponents, then multiplying / dividing, then you're adding and subtracting. And you always do math in this order. Have to. And I'm going to do order of operations to explain to you in the hardest form you'll ever see it how to solve this. But we're going to move forward. So if there's an x in here and we solve for x, we'd have to do backwards order of operations. But because there's no x and we're just solving what this math equals, we do forward order of operations. So in math, the strongest operation in the entire world is any form of grouping you see. You might have been taught that parentheses was first, because parentheses is the most common form of grouping. However, it's not the only one. There's tons of secret grouping that exist. Like anytime you have a fraction, the entire top of the fraction, like this example, the whole thing's a fraction because there's a top divided by, fraction line means divided by the bottom. So the whole top is its own group. The whole numerator is one group, and then the whole denominator is its own group. So before I can divide, so my last step is going to be dividing the top with the bottom, but first I have to figure out which each group equals. So each group, I have to like separate them and think of them as different groups until I group them into one number. So grouping means turn into one number. So we group them all together into one number. So all of this on top means something and it can turn into one number, and then the whole bottom can get grouped into one number. So that's the biggest grouping, is the fact that this whole thing's in a fraction. So now if I take each grouping and look at it separately, for the sake of being able to see it on this one, I'm going to delete the bottom out. We're going to only focus on the top grouping of the big fraction for a second. So this is the top. And then within this grouping, we have a couple more groupings. Well, let's talk about the square root, because root is one of our groupings. It's already grouped into one number. It's just a 16. It's been grouped. I don't have to regroup anything because it's been grouped. So then let's look at my parentheses, because there's a fraction, but the fraction's in my parentheses. So this is the next group as I move in, like as I zoom in. So I had the group of it being on top, and in this group, the next group is this parentheses. So this parentheses, I have to combine into one number first. So for a minute, I'm not going to think about this times 3 or anything after it. I'm just going to think about the fact that I have to group this part. Well, to group it, I have to restart order of operations. So if I restart, the first one's grouping. Is there a grouping in here? Well, there is, because there's a fraction in here. So this fraction has to be grouped to one number first. So I don't have to think about u plus 5. Not yet, anyway. So now I have to group this, or to solve this into one group. Well, to do that, I have to restart order of operations. Oh, look, the first thing's grouping. Is there a group within my group? Well, because the numerator is not one number, it needs to be grouped together first. The 3 is already grouped to one number. It's just a 3. So I don't need to think about that part yet. I just have to turn the top into one number first. To do that, I have to restart order of operations. So the first one's grouping. Is there any grouping in this? No, I don't see any parentheses. I don't see any roots. I don't see any fractions. This is my very first grouping that I must deal with, is just the top right here. So next is exponents. The next strongest thing is any exponents. Well, I do have an exponent. I have a 4 squared. And 4 squared is what? 16. So I can replace it with 16. So next would be multiply divide, and I don't have any multiply divide in this part right here. And then the last is any subtracting or adding, and I do have 16 minus 1, and so that can group into being 15. Now I've figured out that the whole top of this part up here, the 4 squared minus 1, is 15. So I can replace it with the fact that it's 15. It's been grouped together now into one number. So this 15 over 3, if I go back and bring my whole top grouping back, so remember 15 over 3 was this part right here. The 4 squared minus 1 was the 15 over 3. So I'm still working in this big parentheses grouping, so I'm just going to ignore this part for now, ignore the squared part for now, ignore the plus 16, because I'm still working on figuring out this part. But remember, this top part was 15. And then 15 divided by 3 equals 5. And I do that division, because fraction means division. So that means this whole part right here is 5. So I can replace that with 5. So I don't need any of this because I used it. But now what is 5 plus 5? 10. So if I go back to my original top grouping and replace the stuff I figured out, I know this whole middle, this 5 plus this part became 5, this whole middle now grouped to one number became 10. So I've now officially grouped this entire parentheses part. All right, so now I have my whole top of my fraction. So I have 3 times in this whole middle grouped to 10, squared plus 6, the square root of 16. So now to continue this, I have to restart order of operations. So after each step, you basically restart order of operations. Is there any grouping? No, everything's one number. Under the square root's one number, in the parentheses one number, outside of the parentheses one number. Everything supposed to be grouped has been grouped. Do I see any exponents on this now? I do. I see 10 being squared, and 10 times 10 is 100. So I replace 10 squared with 100. Do I see any other exponents? Remember, the square root is just an exponent. So the square root of 16 becomes 4. So now I've done the exponent step. do I have any multiply / divide? I do. 3 parentheses 100 means times 100. So 3 times 100 is 300. And now I have 300 plus 4. And 300 plus 4 is 304, which means I have officially grouped my entire numerator, my entire top of my fraction is 304. So now I have to group my whole bottom to figure out what the bottom is so that I can end up dividing. So I pulled this whole bottom out so that we can focus on grouping it. So when I restart gems, G for grouping, is there any grouping in my grouping of the denominator? Yep, I definitely see a parentheses. So I have to start with this part. So I'm just going to copy and start with the parentheses. And I need to group all the numbers in the parentheses into one number. To do that, I have to restart order of operations. And my first step in order of operations is G for grouping. So is there a grouping in my parentheses? There is the fraction right here. So I have to deal with the fraction first. So I'm going to focus on that first. Now, in my fraction, to simplify it, I have to restart order of operations, and my first step is grouping. So my bottom has been grouped, my top has not. So to group my top, I just have to do that one step, is 13 minus 1 becomes 12. And then now I can do the step, since the top's been grouped and the bottom's been grouped, I can divide them, and 12 divided by 3 is 4. Which means this whole fraction was the same thing as 4. So I have the negative, and now that fraction became 4 minus 1 plus 1. To solve this, I have to restart order of operations. Do I have any grouping in this? Any roots, fractions, or parentheses? I do have a parentheses that has more than one number in it, so I have to group them together. And 4 minus 1 is just one step. 4 minus 1 is 3. So now, do I have, so to finish this out, I have to restart order of operations. Do I have any grouping to be done? No. Do I have any multiplying to be done or dividing? Yes, because negative parentheses 3 means negative times positive 3. And a negative times a positive just becomes negative. So now that's negative 3. And finally, do I have any adding or subtracting to do? I do. Negative 3 plus 1 becomes negative 2. So after grouping my whole denominator by following all the steps in order, figured out the bottom is the same thing as negative 2 when grouped together. So finally, my last step to solve this is I just have the fraction, which means divide, and 304 divided by negative 2 equals negative 152. So that's the answer to this when I do forward order of operations. So when you have to solve for x, you always have to go backwards. Since this all equals negative 152, I can change any one of these numbers, like this 5, and I can make it x. And when you solve for x, the answer has to be 5, because it was a 5 right here that made this whole thing equal 102. So I could also, instead of this 4, I could put an x there. And then when I solve for this x, I would have found it to be 4, because that's what it was when it made it equal 152. So in order to solve for x, you have to use all of the inverses of each operation and go backwards and backwards of order of operations to end up isolating that variable. So let's say this is my example. And let's say I'm going to tell you that x, I know the answer, x is 10. So then what does it have to equal? So if I do this math going forward, first I start with grouping, and the bottom's already grouped, but the top's not, so I have to start with solving the top of the fraction. In the top of the fraction, I have a parentheses that I need to group first. So I still have the negative 4, but when I do the 10 minus 5 in my parentheses, I get 5. And then I'm still squaring it. So now my next step is in my top grouping, because I still need to group all these numbers, the negative 4, the 5, and the squared, to one number. But do I have any more grouping I have to do in that top? I don't. So now I get to move on to exponents. Are there any exponents in my numerator? Yes, I have that 5 being squared, so I still have -4. But when I do 5 times 5, I get 25. And it's still getting, the bottom's still the same. Next, in my numerator, I don't have any more exponents, so I get to move on to multiplying/dividing. I do have a multiplying because a number in front of a parentheses means to multiply. And -4 times 25 is -100. And now my top has been grouped into one number. So I'm done with grouping my top. There's nothing to group on bottom. So I just get to move to the step where I divide these two, and -100 divided by 10 is -10. So with this x, when x was 10, the answer is -10. So then let's pretend I didn't know that x equaled 10. I thought it was an x. And what they told me about it was that it equaled -10. I have to figure out what number I can put right here so that it equals at the end -10. Well, we already know the answer was 10 because I had to plug a 10 in here in order to get out that answer of -10 by the end of it all. So to solve for x, there's many ways to think about it, but I'm going to teach you the easiest way to make sure that you never make any mistakes. And then if your brain starts to recognize patterns and can move faster, that's great. But I'm going to break it apart. So what you do is you say in the forward order, if I knew what x was, if I knew the answer was 10, what is the math that's going on in what order? And we're going to list everything in order that happens to x. So here's how it works. When we knew x was 10, the first thing we did was we took x, and we subtracted 5. And then we got the answer of 5. But the first thing we did was group these two together. The next thing we did was this 5, we did the squared, and it turned into 25. So then we took it, whatever it was, and then we squared it. And then that's how we got that 25. Then from here to here, what changed was it became 100. And we did that by multiplying the 25 we had by the -4 that was in front. And that's how we got that -100. And so now we're on this step. Then to go from here to here, the last thing we did was we took our answer that we're on and we divided it by that 10. That's the order we went in to get their final answer. So now, if I know what the final answer is, but I don't know the value of this x, in order to solve for x, you use the inverse of each one in the backwards order because you have to basically undo it. So if the strongest thing was to subtract the 5 in the parentheses, that's going to be the last thing we get rid of because it's too close to x. It's stuck being squared with x. So I can't just add 5 over right now. It's stuck in this parentheses. I have to get rid of the parentheses first. And it's stuck being divided by 10, so I have to get rid of that first. So since the last step we do in forward order of operation would have been divided by 10, then it becomes the first thing we do to solve for x to get rid of it. So the inverse of dividing is multiplying. So the first thing we have to do is multiply by that 10 to make it go away. So because it is the weakest step, since it's the last thing that happens, pretend like x is like the princess and all the math around it's the dragon and the bad things you have to fight, and the strongest one's closest to the princess, and the weakest one is the one the furthest away, the last thing we do. So in order to slay the beast and save the princess, you're going to want to start by getting rid of the weakest one first. So since dividing by 10 was the last thing that happened, it was the weakest one. So to get rid of it, to slay it, we have to use its inverse and multiply by 10 to make it go away. So I have to put both sides in parentheses, multiply both sides by 10. This side, it cancels because multiplying cancels the division. This side, though, so I still have on this side the -4 parentheses x minus 5 being squared. But now it's going to equal -10 times 10 is -100. All right. So that would be step 1 in solving for x. Step 2, the next weakest thing. So we've taken care of this step. Next, it was the fact that they multiplied by 4. So the inverse of multiplying is dividing. So we have to divide by that -4 to solve for x. So that means in the step, I have to divide both sides by -4. This side, -4 divided by -4 cancel and become 1. So I just have 1 parentheses now. Instead of -4 of them, I just have 1 parentheses of x minus 5 being squared. But then on the other side, -100 divided by 4 is -25. Oh, just kidding, because this was a -4, this is a -4, and a negative divided by a negative becomes +25. So mathematically, the next weakest thing, so I took care of this guy, he's gone. Took care of this guy, he's gone. Now is the fact that we squared it was the next weakest thing. So, and you can see everything's trapped in the parentheses getting squared. So that's the next thing I need to get rid of. So what's the inverse of squaring something? Remember, there's 2 answers to this one. You could say the square root. Or you could have said, take the parentheses around it and raise it to the exponent of 1/2, but that's the same thing as taking the square root. So I'm going to take the square root of both sides. The square root cancels the squared because they're inverses. They eliminate each other. So then I'm left with x minus 5, and it's not in a parentheses anymore. Because the point of the parentheses was the fact that it was getting squared. It's not getting squared anymore because we got rid of it. And then equals the square root of 25 is 5. And so finally, the last step we have was because x was getting subtracted by 5. That's the first thing that was happening to x. It's the last thing we get rid of. To undo subtracting 5, we add 5. So if I add 5 to both sides, minus 5 plus 5 cancels, and it becomes x only, equaling 10, which we knew because that's what I plugged in the first place to get the answer of the -10. But that's how you do it. So remember, you always start with the weakest one and get rid of it first by doing the inverse. Then the next weakest, then the next weakest, then the next weakest. So it's like, if this is going forward to get the answer, then we do the inverses backwards to solve for x. All right, let's say I have something like this and I want to solve for x. So first of all, because it says 28 equals, it's no different than if it said equals 28. It doesn't matter what side that goes on. So write it however you feel more comfortable with. I'm going to do it like this because this is the way I like it. So then, what I could do is I could put a number in for x, like I did on the last one. Like, let's say, it's not going to equal 28, whatever number I put in there. Let's say I put in 6. And then I just do whatever math that would happen to 6, and I'd write it out in order so that I remembered as I did it. Or I can think in my head, okay, let's do order of operations. The first thing's grouping. If I put a 6 in there, there's nothing to group with 6. It's just one number. So there's no grouping. In my fraction, both the numbers are already grouped. So there's no parentheses. I don't see any grouping. Next, I move on to exponents. So if there's a number in here, the first thing that would happen to it is it'd get squared. Then whatever my answer is, I always times it to the top of the fraction. So times by 1. Then I divide it by the bottom of the fraction, which is a 3. That's how you do fractions. Is you always start with timesing by the top, then divide by the bottom. And so that's multiplying and dividing. And then the last step of order of operations is add or subtract. And I have this plus 1 to add. So that's everything that happened to x if I knew what x was. So then to solve for x, I have to do it backwards. Or if the weakest thing is to add 1, to get rid of it, I do what? Our first step would be to subtract 1. Do it to both sides. So you end up with an answer of 1/3 x squared equals 27 after I subtract that one. So I took care of this one down here. Here, I'm going to change the color. I took care of it. All right. Next, weakest thing was dividing by 3. So to undo dividing by 3, I should do what? The inverse of division is multiplication. So I'm going to multiply both sides by 3. So then the 3's cancel, and I'm left with 1 x squared equaling 27 times 3 is 81. And so now I took care of the whole divide by 3 part. Here's the thing about the times by 1. Anything times 1 is just itself. So 1x squared is just x squared. Here's the thing about the whole times by 1 part. When you multiply by 1, since 1 is the identity for multiplication, it doesn't change anything. 1x squared is just x squared. So because it's a 1, I don't actually have to get rid of it. Like this isn't a step I have to reverse. Because the reverse of multiplying by 1, here I should have wrote multiplying. The reverse of multiplying by 1 is dividing by 1. And 1 divided by 1 is still just 1. And 1x squared is just x squared. So because it's the identity, I don't actually need to do anything with that step. And finally, oh, it wasn't equal 27. It's equal 81. Silly me. Because I needed 20 times that 27 by 3 to get that 81. I just copied it wrong. So now finally, to get rid of the squared, the inverse of squaring something is square root. So x equals the square root of 81 is 9. Don't forget it's also negative 9. The square roots always have 2 answers. I'm going to show you why real fast. If I took this and I put, instead of positive 9 in here, let's say it was negative 9. Negative 9 squared is still 81 because a negative times a negative is still positive. So then when I do 81 times 1 is still 81. I don't even have to times it by the 1. And then divide it by 3, I get 27. So then this whole thing becomes 27. And 27 plus 1 is 28. So both answers are right if I put positive 9 in there or if I put negative 9 in there. It does end up equaling 28. So that's how you solve for x with exponents. They do like to make it a little harder, where they make a lot of them letters. And so you're not going to end up having a number solution like this. So I need to show you a couple of those. This one wants us to solve for t. So t is the one we need to get all alone. So when we follow order of operations, we just need to write the order of what happens to t. Well, is there any grouping? No, there's no parentheses, no fractions that aren't already grouped because the 2 and the 5 are each one number. No roots, there's no grouping. Is there any exponents with t? Yes, t is getting squared. All right, what's happening next? Do I have any multiplying or dividing? Well, I do. I have tons of multiplying and dividing. Remember, this equal r can go at the end. And I do like writing those things at the end. So then the next thing is right next to the t, in front of it's the s. And when two letters are side by side like that, it means it's getting multiplied by that s. Next, in front of the s is a fraction. And the numbers next to letters also mean multiply. So we're multiplying by this fraction. But remember, fractions don't just mean multiply. It means multiply by the top, the numerator, which is 2, but then the bottom of the fraction means to divide by the bottom of the fraction, which is 5. And then if I knew what the numbers were, like if I knew what t was and s, then I would have a number answer. But I don't know all of the numbers, and these are a bunch of letters. However, the math works in the exact same way. You're just going to do backwards of the order of operations that happen to that t and isolate it until you get t alone. So to do that, the weakest thing was dividing by the 5. So the first thing to get rid of it, the inverse of dividing is multiplying, so I multiply it away. These cancel. So then I have S2 from the 2, then the S, then the T, getting squared, equaling R times 5 is just 5R, because we always write the numbers first. So I took care of this step. Next, I need to take care of the multiply by 2 step. The inverse of multiplying is dividing, so I'm going to divide that 2 away. So the 2's cancel, so then I just have S T squared equals, I could do 5 divided by 2, but I'd get 2.5, and that's a decimal. So I'd rather leave it as a fraction. So I got rid of the multiplied by 2. Next weakest is multiplied by s. To undo that, I divide by s. However, when I divide this side by s, it just means it joins the bottom. So then finally, because I got rid of the multiplied by s, and so these cancel, so then I'm left to t squared. So t squared equals this whole side. However, I'm running out of room, so I'm going to go ahead and move my math over to this side. So I'm at t squared equaling all of this (5r) divided by 2s. And finally, for the squared, the inverse of squared is square root. So I square root both sides. The square root and the squared cancels. So then I'm left with the fact that t equals, remember, since it's a square root, you write plus minus. The square root of, and I can't combine any of this together because the numbers give me decimals and the letters are different letters. So as weird as this looks, this is my answer. T equals all of this, and this is what they'd expect from you. And they could have told you to solve for S or any other letter, but we picked T. Oh, I should probably mark that we did that one. And then we freed the princess. All right. I'm going to do another example. This one wants us to solve for X, and there's a bunch of letters. So I'm going to first type out everything that is happening to the X in order of operations. So if I knew what X was, X is stuck on top of a fraction, so I need to group the top first. It's then stuck in the parentheses, and so I need to combine the parentheses into one grouping first. So the first thing I do to X is I'd subtract the P. After I'd subtract the P and got one number, The next thing in order of operations is exponents, and I have one, so I'd have to square that number. So then I'd have to square it. Then once I've squared it, the times 3 in front would be the last step, multiplied by 3, before the whole top was one number. And then now that the whole top is one number, I would have to divide by that bottom. And if I knew L, I'd have to multiply them together. However, we don't know L, so I could just write divide by 5L. So then to solve for X, I'm just going to go backwards. So the inverse of dividing by the 5L is to multiply it away. So I multiply both sides by 5L. These two cancel. I'm going to switch colors. So then I have the undone dividing by 5L. On this side, I have 5LT. It doesn't matter which letter I write first as long as my number goes first. Equals, and then on this side, the denominator canceled because we multiplied it away. But I still have 3 parentheses x minus p getting squared. So the next strongest thing that I have to defeat is the multiply by 3. The inverse of multiplying is divide, so I have to divide both sides by 3. If I did 5 divided by 3, I'd get a decimal. So I'm just going to leave it looking like this. So the 3 divided by 3 cancels. Now if I'm trying to save x, it's getting minus from p, but that's all stuck in a parentheses that's being squared. So I got rid of multiplying by 3, but the next thing to get rid of is my squared. And to undo squared, I do what? We square root. I have to take the square root of both sides. These cancel. Square root of this side too, but then I have to remember the plus minus. I can't take the square root of letters or the 5 or the 3 because 5 and 3 are prime numbers. And so I just kind of leave it looking weird like that. Since I took the square root of both sides, I don't need the parentheses squared anymore because I got rid of it with the square root. And so finally, I've divided by 5L, got rid of that, got rid of multiplied by 3, got rid of the squared. I have to get rid of the fact that we're subtracting p. The inverse of subtracting is adding, so I have to add p to both sides. It doesn't matter if you write it first in front, just p plus minus this stuff, or if you added it to the end. It really doesn't matter as far as the answer goes. It's just that the answer is p plus or minus the square root of 5 LT over 3. And that's what x equals. And like I said, it doesn't matter if you put the p here or if you wrote after the square root plus p, as long as it's not under there like that. So if you wrote it like that, or if you put the p in the front, it doesn't matter. And then that would be the answer for this one.